Welcome back to Physics 142. We've been talking about torque from magnetic fields, and in this video I want to think about one more example and sort of a big application of the fact that magnetic fields applied to current loops produce torque. And to think about this, I want us first to just consider this following example, all right? I want to think about a current loop here, so I've drawn a current loop in black, all right? And I'm going to apply a magnetic field across that current loop. So I've drawn a magnetic field here in green across this current loop. And let's suppose that I start running some current in this loop, all right? Maybe I start running 2 amps of current or something like that, all right? Well, we know that that should produce a torque. And one of the things I want us to just be able to sort of get a sense of is, well, what way will that rotation, what will be the sense of rotation? What we might first ask, like, which axis will it rotate around? Well, how are we going to approach this problem, right? How do you think about the direction of the rotation, the direction that the loop will rotate? Well, remember, we have our formula that says that torque is the area vector, the current times the area vector crossed with the magnetic field. So, well, the area vector, remember, there's 2 choices for the area vector here, right? Depending on if I start the current counterclockwise or clockwise, the area vector will either be into the page or out of the page, right? Those will sort of be my options. Well, let's think, what will happen if, say, I start it counterclockwise, all right? If I start it counterclockwise, that means my area vector will be out of the page, right? Area vector out of the page, and I need to then curl my fingers towards B, right? And my thumb would point to the left. If instead the area vector, I run the current the other way, if instead I ran the current clockwise here, if I ran the current clockwise, well, that would make the area vector go into the page, and if the area vector is into the page and the magnetic field is up, then my finger would point to the right, right? It would just flip the other way. So we know that the resulting vector, the torque vector, either is going to point to the left or to the right. So that means that in this case, it must rotate around axis number 2, all right? Well, the answer is it's going to rotate around axis number 2. Now, if we get a little more specific, and let's just choose that I'm running my current in the clockwise direction, all right? If I'm running my current in the clockwise direction, we said if I run my current in the clockwise direction, then the area vector, right? Then the area vector here, the area vector is going to point into the page. Remember, into the page, we use a little X. It's like the feathers of an arrow or something like that going away, right? So that's into the page there. That's the direction of my area vector. And so when we took that cross product, then we do into the page crossed with up. That gives us a resulting torque vector that is this way, right? The resulting torque vector of those 2 will be to the right. So what does that mean about the rotation? Right? What does that mean about the rotation? Well, we need to think about, all right, it's going to be rotating around, the torque direction shows you the axis it will rotate around, right? So it's going to rotate around this axis 2, and so I point my thumb along that axis. I need to curl my fingers in the sense of rotation, and that seems to suggest to me that this is going to rotate in a way where the top will start coming toward us, right? And the bottom will go away from us, right? So the rotation will be this top part will come toward us, and the bottom will go away from us, right? The bottom will go away from us. So, if I'm trying to sort of sketch that sense, something sort of like this, right? That's going to be the sense of the rotation here. Now, that's all well and good, but there's something else that I want us to think about here, all right, is, well, as it rotates, all right, now we have this loop starting to rotate, all right, what's going to happen after it's rotated for a while? And to sort of think about that, I maybe want to draw a little bit of a side view here, all right, so let's draw a side view. All right, here we go. We're drawing a side view, and we want the magnetic field, if we're sort of taking a side view here, right? The magnetic field originally was going sideways, right? So there's the magnetic field going sideways, right? And that area vector, the area vector we said was pointing into the page, which I guess would be sort of down here, right? This would be the direction of the area vector. And, you know, my hoop sort of from the side view sort of looks like this, right? Okay, well, now we know this is going to start rotating, right? And so this part starts rotating up, this part starts rotating down, and so after a while, it'll have rotated a little bit like that. Right now, my area vector, you know, new area vector is going to be pointing this way, and you can see that the angle between A and B is getting smaller, right? The angle between them is getting smaller. If you remember from cross products, it depends on the sign of the angle between them, so the more and more these point in the same direction, the smaller the torque gets, until you can see if we've actually, you know, tipped this all the way so that from the side view, now my hoop just has the magnetic field going through it, right, rather than across it. Well, now the area vector and the magnetic field, they're pointed in the same direction, and we're not going to get any torque at all, right? Things get even a little bit more interesting, right? Well, you know, you could imagine we've had a torque applied through all of this, right? So that's the force, so presumably it has some velocity, so that will carry it past, you know, just being in this configuration, right? It, you know, the hoop started like this, it went to like this, right? Now it'll carry it past, and now you have essentially the situation of the area of sort of, you know, from its perspective, the current flowing the other direction, right? We've now taken and flipped this up, right? If we're going to flip it over, then from the perspective of the B field, that's essentially the current flowing the other direction, and that means that the torque will reverse, right? When the area vector is going this way, then the torque will reverse its direction. So this has, the reason that I talk about all this and bring this up is that the major application of using magnetic fields to produce torques is that this is a way that you can produce a motor using electric currents. This is a way that you can get kinetic energy out of just an electric current, right? And to see how that works, right? Well, if we start with a current, the current is actually making something move, right? Once we run that current in a magnetic field, you start getting this rotation, right? You could imagine this is some sort of axle or something, right? And you start getting it rotated. And that means you're actually getting motion, right? This is a great way that, you know, you could produce basically like an electric motor, right? If you run some current through a wire in a magnetic field, you would make the axles rotate. Except we have the problem that as soon as you get part way, then you have this issue that it's going to want to rotate back the other way, right? And so that's not very good for an actual motor. And so what people do in practice to solve this problem is that once the loop is rotated up to the point where it's no torque, you take and you reverse the current direction, right? Then you take and you run the current the other way, and that will then give you an additional push that sort of makes you want to continue to rotate. So every half turn, you reverse the direction of the current, and that will produce sort of a continuous torque that then will make this accelerate and make your motor run and operate. And I will share a couple links to some useful videos that actually demonstrate this phenomenon. So one big application of this is how you can make an electric motor by running a current through a magnetic field.